Okay, we want to solve this equation. Left-hand side is just the same as what we did, but now we've got a right-hand side. This is called a non-homogeneous equation because you don't have a zero here. Okay, you've got a t squared, and this is the non-homogeneous part of the equation. So we solve this, in this case, in a way very similar to what we did last time. Trial solution is going to be, we're just going to throw a bunch of powers of t in here and see if we get something. Okay? Now the rationale is, if we take two derivatives of t to the fourth, we're going to get a t squared, right? So we don't want to use anything over t to the fourth, because if we do, y double prime is going to give us a t cubed, right? And we don't have a t cubed over here, so there's really turns out there's no point in that. It also turns out there's really no point in including t to the fourth and t cubed here, because our 6y will then contain a t to the fourth and a t cubed, okay? And we'll see how that all works out, because I want to do this overkill solution so we know how to prune a solution down a little bit. This is called our trial solution. And we usually put a P on this. That'll be a trial particular solution, but we'll get that terminology later. We want to just get the idea of how we deal with this. So we take our derivatives, we get this and this, we verify that this is correct, and then we rewrite the equation, right? Okay, well, okay, that's great, but we want this equation to be equal to t squared. Not just equal, but identically equal, meaning equal for any possible value of t. So what we do is we're going to write this as some multiple of t to the fourth plus some multiple of t cubed plus a multiple of t squared plus a multiple of t plus some constant quantity is equal to t squared. So it's easy to collect all our t to the fourth terms, our t cubed, our t squared, our t, and our constant terms, okay? For example, t to the fourth, there's just one t to the fourth here, that's going to be 6 and 4 t to the fourth, right? So we know what's going to go in here. And then there are only two t cubed terms in the whole thing, this one and this one. And then there are 3 t squared terms and 4 t terms and 5 constant terms, okay? So each of these will be a little longer than the one before, but then the key is going to be just that, well, this has to be identically equal to t squared. If it's going to be identically equal to t squared, meaning equal for any possible value of t, then this, and this all have to be 0, and this has to be 1, right? So we're going to get 5 simultaneous equations in our 5 constants. Okay, but they're going to actually turn out to be very easy to solve, because at least 2 of our constants are going to be 0. And then we're only going to have 3 equations, and a lot of those will be kind of short. So it'll be fairly easy to solve them. Okay, you can almost just do a back substitution from the very beginning, as you'll see when you do it. So go ahead.
Okay.